Hello, I am Yash. Our project is Huffman Compression Web App. The problem: digital data is huge, storing and sending it is slow and expensive. We need a way to make files smaller without losing data. Our solution is this web app that uses Huffman coding, a classic data structure algorithm, to compress files 100% in your browser. The core idea is simple: frequent characters get short binary codes, rare characters get long ones. This is built using two key data structures, a mean heap and a binary tree. The algorithm works in two stages. First, we use a mean heap to efficiently find the two rarest characters and combine them into a tree. We repeat this until we find a single Huffman tree. Second, we traverse that tree to generate the binary codes for each character. I built the core React UI and state management. I also wrote the initial backend logic, the Huffman node class, and the frequency counting map.
I am Mandan Patel. My contribution was implementing the core backend algorithm starting with the mini. Here is our mini class. It's array based and has the key insert and extract min methods which both run in order of log and time. This efficiency is critical. I am also wrote the main tree building loop. It insert all nodes into the heap that extract the two minimums, create a parent and insert it back, repeating until only the root node is left. Finally, I am implemented this recursive generated code function. It traverses the tree left at 0, right at 1 to build the final binary codes. Now Chintan will show how we pack this.
Okay, so I am Chintan and I was responsible for the backend logic of file generation and advanced image compression. So here is the serialize and deserialize functions that I have made, and for the decompression the file must contain the tree itself. I implemented this serialize tree function that flattens the tree into compact string to store as metadata. And the other thing was to image compression. I also extended this and it's a bit complex. I wrote the delta encoding function which finds the difference between pixel values to create more repetition. So here is the code of Huffman JS, where we wrote the function which will amplify the mean heap function and compress the image. Also, I will talk about encoding pipeline. I then build the main encoding pipeline that applies this, where each RGBA channels compresses separately and packs it all into the final downloadable file. Now Kavya will show you the demo.
I am Kavya. I built the React components for the demo. I was also responsible for implementing the entire decompression algorithm. This involves reading the file metadata, deserializing the tree, and then decoding the binary data. So here is our app. So now I will drag a sample text file and compress it. So initially you can see its size is 6.19 MB and the compressed size is 3.15 MB, and we have saved 43.23% of the space. You can also see the Huffman code table over here. So for each character there is a fixed Huffman code assigned to it. Now I will decompress the sample.huffman file. So as you can see, I have successfully decompressed that file. So from 3.19 MB, it's restored its original size 6.19 MB, and now we can download this file and save it. My logic can also handle images. So for images, I can drag a sample image file, as you can see over here, and then compress it. So it's, as you can see over here, its original size is 7.03 MB and its compressed size is around 3.81 MB, and we have saved around 45.84% of the space, and we can download this .huffman file, and for the same we can decompress that same file from here, and I'm dragging it and then I'm decompressing it. So as you can see, we have successfully decompressed our compressed file, so it is restored its original file size, and then we can download that file and we can save wherever we want. So in conclusion, our project successfully applies data structures like mean heaps and binary trees to solve a real world problem. We are proud to have a fully functional web app. Thank you, and do check out our code on GitHub.